As we begin our study of basic hydraulics, we must first recognize that fluid power is another method of transferring energy. This energy transfer is from a prime mover or input power source to an actuator or output device. This means of energy transfer, although not always the most efficient, where properly applied may provide optimum work control. Energy may be defined as the ability to do work. Work is defined as force through distance. If we move 1,000 pounds a distance of 2 feet, we have accomplished work. We measure the amount of work in foot-pounds. In our example, we have moved 1,000 pounds 2 feet or have accomplished 2,000 foot-pounds of work. Power may be defined as the rate of doing work, or work over time in seconds. If we lift 1,000 pounds 2 feet in 2 seconds, we have accomplished 1,000 units of power, or 1,000 times 2 divided by 2 seconds. To give us relative meaning for measuring power, we must convert this to horsepower, which is a unit of measuring energy. Mathematically, hydraulic horsepower is expressed as follows. Horsepower equals flow in gallons per minute times pressure in pounds per square inch divided by 1,714, a constant. In our illustration, we are lifting 10,000 pounds, this is our force, a distance of 1 foot, this is the work to be accomplished. If we lift our load in 2 seconds, we have defined a power requirement. This may be expressed as hydraulic horsepower. To lift our 10,000 pounds a distance of 1 foot in 2 seconds, we must have a required flow rate at a specific pressure, based on cylinder size and pump flow discharge. In this illustration, a 10-gallon per minute pump is required to extend the cylinder in 2 seconds. The pressure requirement to lift the 10,000 pounds is 1,500 psi, based on cylinder diameter. Based on our formula, our theoretical horsepower requirement would be 8.75. The law of conservation of energy states that energy can neither be created nor destroyed, although it can change its form. Energy in a hydraulic system that is not used for work takes the form of heat. For example, if we have 10 gallons per minute going through a relief valve, which has a pressure setting of 1,500 psi, we can calculate the energy being converted to heat. Torque is twisting force. It is also measured in foot-pounds. In this illustration, we are producing 10 foot-pounds of torque when we apply 10 pounds of force to a foot-long wrench. This same theory applies to hydraulic motors. Hydraulic motors are actuators that are rated in specific torque values at a given pressure. The twisting force, or torque, is the generated work. A motor's RPM at a given torque specifies our energy usage or horsepower requirement. You have completed this training section.